Hey everyone, Mr. Skelton here. We are back at it. Lesson 6 in Unit 4, and today we are going to be solving polynomials by graphing, and more specifically, we're going to be using our graphing calculator to find solutions. Now, you've actually done this before. Again, let me just do a quick recap of kind of what we know. I'm just going to take a basic XY graph, and I'm just going to graph a general cubic function here. Just kind of talk about the big picture. There's your x-axis, there's your y-axis. When we're solving, okay, when we're trying to find solutions of the polynomial, those are the same thing as what we've been calling zeros, right? Zeros are solutions. It's the same exact thing. So when we go to graph or solve by graphing, what are we looking for? We're looking for where the graph crosses the x-axis. Those dots right there are your solutions. That's how we solve, all right? Now, one thing that I want to make you aware of today and remind you of, so I'm just going to put reminder here, that if you have a polynomial, let's say y equals, 2x to the 4th minus 3x to the 3rd plus x minus 15. I'm just making something up here. I want to remind you that when you have it in standard form, that highest degree, like a 4, is the number of solutions. Now, one thing I want to make you aware of is that in today's lesson, we're going to have sometimes all of them be real solutions, like -2, -5, 8, 7, 7.5, 1.2, whatever. But we can also today, and you're going to see this, we're going to have some imaginary solutions. Remember, imaginary are like, 2y, etc. Anything with i's in it are going to be solutions. We can also have multiplicity, okay? And we've talked about that before, where we have the same answer more than once, okay? So you already have some good background knowledge about what these zeros look like on a graph, and that's what we're going to be doing today. So I have a couple examples to go through with you, and you're going to need your graphing calculator, so if you don't have it, go ahead and hit pause real quick and break it out. And what we want to do is I'm going to probably minimize this a little bit so you can get a clear view of the calculator. There she is. Okay, and I'm always going to restart my my memory, reset it. I'm going to hold a memory here, reset, boom. And for this first one, it's y equals, I think it's y equals, or it says x cubed equals, or minus 27 equals 0. We're solving by graphing. So what do we want to do when we do this? What are we looking for? You want to look for where crosses the x-axis, okay? We want to look for where the graph crosses the x-axis. Now, from that, and you're going to see this here in a second, so let's type it in. Let's go to our y equals, let's go x caret button 3 minus 27 and hit graph. You'll notice something, if I can get my calculator in the picture. What do you notice? You notice that this graph is only crossing the x-axis at one spot. Now, you can kind of look. It looks like a 3. We'll just type in a 3 for x. What's 3 cubed? 3 times 3 times 3 is 27. 3 is a solution. I mean, it doesn't take much to figure that out. Now, not only do you want to look for where it crosses the x-axis, but what's the problem we just ran into? We only see one answer. And what do you know about the number of solutions? There's 3 of them. So not only do you want to look for where it crosses the x-axis, but you're going to use your 0. You're going to turn it into a factor, and you're going to use, I would suggest you use synthetic division to find other solutions. Okay? So let's go through that. We know 3 is an answer. We can see it right here. All right? And you can calculate it. Second, calculate. We can go to 0, hit enter. All right? It's going to say left bound. Got to find my cursor somewhere. Nope, went past it. Nope, it's coming up. There it is. Left bound, enter. To the right, enter, enter. There you go. 3 is a solution. Okay. So that's the only real solution. We talked about that right here. We could have some imaginary, and you are going to have some imaginary right here. So let's take a look at what this looks like. I know 3 is a solution. So using synthetic division, I'm going to set up my synthetic division L like this. 3 is my 0. 1, x squared, x constant. I use a little squiggly line there because my last one is going to be my remainder. So I bring down my 1, and I have a 1. 1 times 3 is 3. Add that together, get 3. 3 times 3 is 9. I get 9. 27. I get 0. Okay. Now we already know we're going to get a remainder of 0 because we know 3 is an answer. But what do we have left? We have constant x squared. So x squared plus 3x plus 9. And that's set equal to 0, right? We're still trying to find 2 other solutions. We know x equals 3 is one of our answers. We got to find 2 more. Okay, well, always look to factor. 2 numbers that multiply together give you 9. Add together, you get 3. I don't think so. So this is a quadratic. How do we know how to solve quadratics other than graphing or square rooting? Well, we can complete the square or quadratic formula. And here's where we're going to have to use the quadratic formula. So x equals negative b plus or minus the square root of b squared minus 4 times a times c, all over 2 times a. Okay? So you're probably yelling at me for bringing this back into the fold, but yes, we are going to have to use some quadratic formula. Negative 3 plus or minus the square root of 9 minus 36 all over 2. Okay? And we're going to get 9 minus 36, and you're probably thinking, uh-oh, I get a negative number. You are right. You get negative 27 over 2. So what does that mean? That means we're going to have some imaginary numbers, right? If you need to, off to the side, 27 breaks down into 9 and 3. Square root of 9 is 3, so you get 3 radical 3, but there's a negative. So I get x equals negative 3 plus or minus 3i radical 3 all over 2. I can't take that any further, and that represents your 2 other solutions, right? Negative 3 plus 3i radical 3, negative 3 minus. So you have one solution, and you have the second and third solution here, and they're imaginary. X equals 3 and x equals this are your answers to number 1. Okay? That is a tough problem. That's a challenging one. It has a lot of steps to it, but that's how we're going to do that. Number 2, I think, will work out a little bit nicer for us. So when you have something that's not equal to 0, my suggestion would be to set it equal to 0 so that you can put it in your graphing calculator. You got to think about y equals, right? So I'm going to subtract this over here, this x over here, and I'm going to subtract this 3. So I'm essentially going to get y equals, I'm thinking y equals because I'm going to be graphing it, x to the third plus 3x squared minus x minus 3 is kind of what I'm thinking, even though we know it's set equal to 0 because at the end of the day we are solving. So let's get our graphing calculator back out here. Try to get it in the picture. Go to y equals, clear it, and let's type it in. X to the third plus 3x squared minus x minus 3 graph. So here's a situation where, again, I'm looking at this. I'm going to have 3 solutions. We'll look at my graph, or look at your graph. How many times does it hit the x-axis? It hits it 3 times. So we're not going to have to do the quadratic formula, and we're not going to have imaginary solutions here. So I know you can probably look at this and figure it out, but let's go ahead and just review how to find these using our calc function. Second calc, we want to find the zeros. So I'm going to find the one on the far left. So I'm going to go to the left of it, enter, to the right of it, enter, enter, and I get negative 3, so there's negative 3. Now, here's a choice for you as well. You can use your graphing calculator, or you could take this negative 3 and do synthetic division and find these other 2 using synthetic division and factoring if you want. Totally up to you. I'm going to go second calc again. I'm going to calculate another 0. I'm going to go to the left of this next one, enter, to the right of it, enter, enter. I get x equals negative 1. And I'm going to do it one more time, second calc 0, to the left, enter, to the right, enter, enter, and x equals positive 1. 3 solutions, degree of 3, all set, you bet. It's nice when it works out that way. Okay? All right, let's turn the page. So we have our next question, says, again, solve by graphing. And first thing we want to do is get this set equal to 0. So I'm going to have essentially 0 equals x to the third. I'm just going to add this 3 over here, minus 2x squared plus 3. And we're going to put that into our graphing calculator. So y equals clear. Squared. Okay, what do we see? What do you notice? Hopefully, the first thing you notice is that it crosses the x-axis one time. We should have 3 solutions because our highest degree is a 3. That tells you we're probably going to have some imaginary solutions, and we're going to kind of do what we did in question number 1. First things first, let's calculate that 1, 0, that real 0 that we know. So left bound, enter, right bound, enter, enter. We get x equals -1. Okay? And again, because we don't see it crossing the x-axis, we know we're going to have to go through a different route here to figure out our other 2 zeros. All right, so I'm going to clear this and remove, and I'm going to set up my synthetic division here to find what I have. So -1, and I have x to the third. There's my x squared. I'm going to plug a 0 for my x, and then I have a 3, right? If you have a missing, there's x3, x2. I don't have an x, so I got to put a 0 in there. Squiggly line for reminder. Drop your first number down, multiply and add. -1, add those is -3. Times -1, -3, +3, add. 3, -3, 0. Now, again, we already know that x equals 1 is a solution, so we better get a remainder of 0 here, or else we did something wrong with our synthetic division. I'm more concerned about this here because I need to translate this into an expression. That's your constant, that's your x squared. So x squared minus 3x plus 3. Look at that, see if we can factor it. We know we can't because we're going to get an imaginary answer, and we're off and running with our quadratic formula. So x equals -b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So I'm going to get +3 plus or minus, I'm going to get 9 minus 12 over 2. So I'm going to get 3 plus or minus the square root of -3 over 2. And I'm going to get, running out of space here a little bit, I'll just shift it right there. So I'm going to get 3 plus or minus I radical 3 over 2. And those are your, so this is your first solution, and this is solution 2 and solution 3 because I have the plus or the minus there. Okay? So very similar to the first question we did. All right, we got an application question here down towards the bottom. It's a dog kennel, the old dog kennel. All right. A particular dog kennel is 7 feet longer than it is wide, and 1 foot shorter than its width. If the volume is 5.9 cubic feet, how wide is it in inches? Ooh, so we got feet and we got inches here. We'll come back to that towards the end. I noticed that when I read it. Let's first talk about what we're dealing with here, which is volume, right? Length times width times height. And now we're going to have to figure out what we're going to use in terms of expressions for our length, our width, and our height. So a particular dog kennel is 7 feet longer than it is wide. So I'm going to go W plus 7. I'm going to call my width, and my height, it says in 1 foot shorter than its width. So 1 foot shorter than its width is going to be W minus 1 foot shorter. Okay? And that equals our volume, which is 5.9. Now, there's 2 ways to do this. Now, I'm going to kind of keep it consistent. Remember, what we want to do if we're going to use our graphing calculator here, which is what we've been talking about in this lesson, is we want to, these are factors, right? So now what we want to do is put this into standard form because we got to get this thing set equal to 0. So I'm going to multiply these 2 together right here. And so I'll have W squared plus 7W. And then I'm going to multiply that by W minus 1. So I'm going to have W cubed. I'm going to go kind of slow here so I don't make a make a mistake, I almost did, so that's a minus w squared. W squared times w cubed, w squared times a negative 1 is minus w squared. That's going to be a positive 7w squared and a minus 7w. So I get w to the third plus 6w squared minus 7w, and that's equal to 5.9. So I want to minus this 5.9 over. And this is what I'm going to plug into my graphing calculator. Okay? So I'm going to go y equals, clear that, and I'm going to go, I have w's, obviously we can use x, so x to the third plus 6x squared minus 7x minus 5.9. Go ahead and hit graph. Okay, now what do we notice? Well, let's talk about this. We do have a cubic function, right? We have a 3 there, so we know we're going to have 3 solutions. If you look at your graph, you'll notice that it is crossing the x-axis in 3 spots. Now, this is a real-world situation, right? And so if it wasn't a real-world situation, we could calculate all 3 of these, and all 3 of those would be our answers. But since we're talking about a dog kennel, we're not going to have negative w's or negative widths. So we just care about this one right here that's on the positive part of the x-axis. So we're going to second calc. We're going to calculate a 0. And I'm going to go left bound there, right bound there, hit enter again. And I get my w, or my x, to be 1.47. And we'll just go to 2 decimal places. All right? So 1.47. Question says, if the volume is 5.9 cubic feet, how wide is it in inches? Well, 1.47, that's its width. If we want to turn that into inches, we need to times that by 12. So I'm just going to go 1.47. I'm going to times that by 12. And I'm going to get about 17.64 inches. Okay, and that's your answer. Last one here, again, another type of question where it's an application to what we're doing. Susan received $1,000 for her 10th birthday. That'd be nice. $800 on her 11th and $300 on her 13th. She saved all her money, and when she turned 14, she had this much in her account. What was her interest rate? Question mark. Hint, her polynomial is in the bank is this. Okay, so let's kind of digest this. Here's the $1,000, X amount of interest, 800, X amount of interest, 300, X amount of interest. We kind of did a problem like this a couple lessons ago, right? So the interest rate is going to be basically, they want to know what X is. The total in her account is going to go here, 2533.29, $2,533.29 equals, that's how much she has after all of this money has been placed into her account and interest has been taken on it. So we have a very similar situation to the problem we just did, right? We had, this was kind of what we came up, what we wrote from the information in the problem, and then I kind of moved that 5.9 back over. So same situation. You could just subtract this the $2,533.29 over to the other side, put all of that in your graphing calculator, and solve. I want to show you a different way to do this question, which is a little bit different than what we did on the previous one. So I want you to envision if we had 2 equations. The first one being y equals the 1,000 x to the 4th plus 800 x to the 3rd plus 300x. And then a second equation just being the amount of money in her account. And so if you used substitution, right, y equals this, you would plug that in right there, and that's how you would get this equation. I want to show you something a little bit different on your graphing calculator. One of the ways, if you recall back in the day in Algebra 1, and even I think we did this in Algebra 2, that you could solve this system, because this is technically a system, right? Equation 1, equation 2, and it's y equals. You could graph both of these lines, and where they intersect, that's your answer, right? where two lines intersect is your solution. So again, this is just a second way to showing you this. So I'm going to go to y equals, and I'm going to type in the first equation, which is 1,000 x to the fourth plus 800 x to the third plus 300 x. My second equation, so I'm going to go down arrow, was my 2533.29. And I'm going to hit graph. Now, obviously, you can't see anything because I have a y equals of 2,533. And so my window needs to get adjusted. So I'm going to go to my y max and type in 4,000. I'm going to scale it at 500. Let's see if that helps us out, if we can see anything here. There you go. Okay. Now, what we're looking for, remember the answer is where two lines intersect. So remember this equation right here, y equals the 2,539. Whenever you have y equals a number, it's always just a pure horizontal line. So what I just highlighted, that's this horizontal line. The equation right above it is my quartic function, because it's a 4. Now it's crossing here at two spots. One's in the negative, one's in the positive. We want to find that intersection point right there. That will be our solution. So what you want to do is go second calc, and we've been using 0, min, and max, but there's also one called intersect. So we just go to intersect. Okay. Now it says first curve. You just move up. So you're on your first curve, which I'm on this part. I'm going to hit yes. Second curve is just on that second line. So hit enter again. Hit enter again. And you get 1.06. Again, we're solving for x here. We know what our y is going to be, so we get 1.06. Okay? So what is our rate? Well, 1.06. So we're basically going to have, if you move it over two spots, you're going to have a 6% rate. Now, I'm going to clear all of this, and I'm going to do what we did the first time, which is if I just subtracted this number to the other side. So 1,000, 1, 2, 3, x raised to the fourth, plus 800 x to the third, minus 2533.29. Hit graph. My scale's all off. I'm going to go to my y min here. Oops. Y min, where's my y min? Go negative 500 graph, just so we can see it. Okay, and I want to find that x. So second calc 0. I'm just using my eyes here. My x is going to be there. Left bound, enter. Right bound, enter, enter. And you can see I get the same thing, 1.06. That's where it crosses the x-axis. So you can use either method. It's just kind of whatever you choose. So this method that I showed you right here is, I'll call it method number 2. This question right here, where we subtracted it and plugged it in, that's what I would call method number 1, where you're just looking for where it crosses the x-axis. Either one, you're going to get the answer of 6%. Okay? So I know it's kind of a lot here. I went through a lot of examples with you, but hopefully you have a good idea how to solve by graphing, and hopefully you understand as well that when you do this, you're not always going to get nice, neat answers. Like on number 2, you may have to use quadratic formula. You may have to use some synthetic division to work it out. If you have questions, I'll be happy to answer them in class and work through any other additional examples you would like to see. Okay? Take care.